Hi everyone, I'll be doing this projectile motion question for you guys. And this from a past paper, it's from Mechanics 2. It's an Edexcel paper from 2023 June. So I think the question paper has around 8 questions, I guess. So if you guys have any other doubts regarding other questions in the paper, you can just drop them in the comments. I can do them for you. And if you have any doubts regarding this question, just drop them in the comments too. So yeah, let's start it. So this say, okay, so they've given us the speed in terms of vectors, 3i plus 2j. Okay, the first question they say is, okay, it's at a height of 20 meters. Then they say by considering energy, find the speed of the ball at the instant immediately before it hits the ground. Okay. So what we can do is, so when using the energy, the conversion energy for by considering energy, so you can't put in vectors, right? You'll have to find the magnitude of the velocity. So it's 3i plus 2g, right? So let me just show you. 3i is onto the x direction, and j is onto the y direction, right? So 3i, 2g. Magnitude is going to be 3 squared plus 2 squared. The square root of the whole thing gives you 9 plus 4. This is square root 13. So the speed of what is it? The speed of the ball is square root 13. Okay. So then what you do is, what we can do is, so the conversion, the energy conversion formula, you can write, just write it down. Change in kinetic energy. It's final, all right, final as F minus the initial, okay? Plus, and when it comes to potential energy, and I'm talking about mgh, okay? So mgh, I'm going to write this plus or minus mgh. So it's plus if it goes up, and it's minus if it goes down. So these are the only two energies we have to consider in this question because they haven't given resistance. There's nothing else acting on it, right? So I'll just write it down. So if they say there's a resistance, let's say there's a, no, let's say this ball has a force and a forward force acting on it. So if they've given extra forces, so you write this down, this equals to, let's say there was a forward force on the ball. So it's going to be F, which is the forward force, into whatever distance it's going. Okay? Subtracted by the resistance. I'll take it as R into the distance. Okay, that's how it goes. So, but in this case, there's no forward force, there's no resistance, none of the. So it's just gonna be equal to 0. The kinetic energy and the potential energy. Okay. So what we can do is, so they're asking us before it hits the ground, right? So final speed half mv squared minus initial speed half mu squared. I'll just write it as mu squared. And since it's going down, you write minus mgh equals to 0. Now this is the formula we use. So half into the mass. What's the mass? Okay, we don't need, okay, they haven't given the mass. It cancels out anyway, so you can cancel out the mass. So half v squared minus half into, okay, so our initial speed was 13. We found it earlier. 3 squared plus 2 squared, which gives you 13. And square root 13 is your initial speed. So if you put square root 13. So this is 13, right? Since it's u squared. Minus u and gh. And g, we take it as 9.8. The most accurate value for g is 9.81, but I think this paper, this syllabus requires 9.8, so I'm just going to use 9.8. You can use 10 also, that doesn't matter. And the height is 20, right? Equals c. So you can write, I'm going to multiply everything by 2, v squared minus 13 minus 9.8 to 20 into 2 equals c. So v squared equals, well, you can take both of them to the other side, so I'm just going to add them. 13 plus 9.8 to 20. It's 405. And so your speed is v squared. V equals 9 root 5, which is 20.1246. So I'm just going to round it to 3 significant figures. All right, that's 20.1. So when you're using the speed for, like, let's say they say something else in the question, just always use this. Don't use the decimals, because 9 root 5 is more accurate than the other values, right? Okay, so that's your first part. Part B, they say find the direction of motion of the ball at the instant immediately before it hits the ground. Okay. So before it hits the ground, and you should know in projectile motion, the vertical velocity changes, but the horizontal velocity remains the same. So for the horizontal velocity, what we can do is, I'll just write down the vector. It's 3 and 2, right? 3i and 2. So for this angle, there's an angle here, right? So you can write that as tan theta equals opposite side of adjacent side. 2 over 3. Theta equals, wait, I'll just, without finding the angle, we'll just find sine theta and cos theta instead. So sine theta is opposite side over the adjacent, which we got as root 13, right? Previously. 9 plus 4, we root 13. And cos theta is adjacent side 3, so adjacent side over root 13. Okay. So your horizontal velocity is root 13 cos theta, right? So it's root 13 into 3 over root 13, which is 3. That's your horizontal. So see, I just wanted to show how you get it. So if you look at your question, this is your horizontal velocity, this is your vertical velocity. So if you want to prove it, this is how you get it. Okay? So 3 meters per second is your horizontal velocity. And the horizontal velocity doesn't change in projectile motion. It's only the vertical velocity. So we can draw a diagram. So we write through it like this. So before impact, the speed was 9 root 5. And the horizontal speed, just from a dotted line. This is 3, right? So this is the angle we need to find. This angle theta, right there. Yeah. Well, that one. because they ask you the direction. You can take the angle either way. You can take this angle too, but you have to mention from which axis you're taking it. If you're taking this angle, you should say you're taking it from the negative y-axis. If you're taking the angle the angle I'm taking, you should take it from the positive x-axis. That's how you should say it. So you're right. So this is the adjacent side, and this is the hypotenuse, right? So cos theta equals the adjacent side over the hypotenuse, which gives you theta cos inverse 3 over 9 root 5. This will give you 81.4 degrees. Okay, so we found the direction. Now part C. They say find the time taken for the ball to travel from A to B. That's easy, right? So what you do is, you found the direction. So we can use V equals U plus AT. Simple equation. We know the final speed, we know the initial. And this time we take it along the vertical axis. So our velocity was 9 root 5. But we are gonna put it to the vertical axis now. So it was 9 root 5. It's gonna be 9 root 5. It's the velocity like along the vertical axis. So it's going to be 9 root 5 sine theta, right? So we can write 9 root 5 sine theta equals in the initial velocity. Okay, and again, when taking the initial velocity, it's not root 13 because we are taking along the vertical axis, right? So along the vertical axis was 2, and it's 2 upwards. Initial, like at the final position, it's downwards, but at the initial position, it goes upwards, which is the opposite direction, right? So when finding time, we need the velocities in one direction. So instead of writing 2, you gotta write -2 because it's in the opposite direction. And the acceleration downwards is 9.8 plus 9.8 t. And 9.5, and that's okay. 9 root 5 sine 81.4 plus 2 equals 9.8. But then calculate it. 9, 5 sine 81.4 plus 2 divided by 9.8. This gives you t equals 2.23 seconds. So that's your time. Okay, now we found all 3 parts, and now we are in the last part. If one part D, is it to find the height h? Okay. It says at the instance when the direction of motion of the ball is perpendicular to 3i. Okay, they say perpendicular to the initial velocity. The ball is h meters above the ground. Okay. So what we can do is perpendicular, right? So we write, let's take the initial velocity. This is 3, this is 2. This h should be perpendicular when the velocity is perpendicular to this. So if it's perpendicular, this should be 90. This we can take it as v. Could take it as v, and yeah, this is root 13. So for it to be perpendicular, the angle we found over here was, we can find it, we didn't find it actually. So tan inverse 2 over 3. This angle is 33.69. So what's this angle going to be? So if it's 90, it should be perpendicular, right? So it's going to be 90 minus 33.6 now. So here, this angle is 56.3. Okay, so now we found the angle. So what we can do is to find velocity. So now you know that the horizontal velocity is always the same, right? So you can write down. So our horizontal velocity was 3, and it never changes. So even at this point, the horizontal velocity is the same because it doesn't change. So you can write V cos 56.3 equals to 3 to find the velocity. So then you can write V equals 3 over cos 56.3. In other words, you could also write it as 3 over, because this is cos 90 minus 33.69, right? So this means 3 over sine 33.69. So which is 3 over sine 33, which is 2 over root 13. So can I get the answers? Okay. So it's 3 root 13 over 2. Yep, 3 root 13 over 2. Now we found the speed. So this is the magnitude of the speed at that point. So which is when the speed is perpendicular to the initial velocity. Okay, so now what we can do is, so we just assume it's somewhere here. I'm just taking it as an example, okay? Let's say it's here. So now we found the speed. So using energy, we can find this height. We can find this height, whatever distance it is, and then we can subtract it with 20, right? To find the height above the ground. So what you can do is, you can write. So we write half, final minus initial, half into m, into now our final is 3 root 13 over 2 squared minus our initial half m. Our initial was root 13, right? 13. And it's going down. So minus m g x. I'm going to take it as x equals to 0. So we can write down. So we can cancel off m. You'll end up with 3 over 2 13. Then you square that and get 39 over 4. Oh, no, sorry. Yeah, no, you get half into 117 over 4. 3 root 13 over 2 squared is 117 over 4 minus half into 13 minus 9.8 x equals to 0. So half. So you can write this, right 117 over 8 minus 13 over 2 gives you 65 over 8 equals 9.8x. Divide this by 9.8. Gives you x equals 0.829 meters. And in the question they ask, find the value of h, which is above the ground. Okay, so what you gotta do is you subtract 20 with 0.829 to find h. So h equals 20 minus 0.829 gives you 19.171. We'll round it to 3 singular figures, so it's 19.2 in 3 singular figures. That's your answer. That's everything for this question. If you guys have any doubts, just drop them in the comment section. And this is also from a past paper question. I think I mentioned it earlier. I'll drop it in the description for just mention of which past paper it is. So yeah, that's everything. Yeah. Have a great day and thank you so much.